today we are actually doing the last section from chapter 4 from before. And we are going to start with 4.8. If it catches up. There we go. 4.8. We're going to talk about complex numbers. Complex numbers have an imaginary component. So we need to start by talking about that imaginary. Alright? I want to remind you where imaginary comes in. If we have the square root of -1, we cannot have a negative underneath the square root. So this negative comes out as an I. Okay, so the square root of -1 is I. So then, if I have I squared, that is technically the square root of -1 squared. So this is going to equal, remember your square root and your squared cancel each other, so this equals -1. Okay? These two we're going to use the most today, but I want to keep going and talk a little bit further. What if I had I to the third power? What do you think that equals? Well, this is the same as saying I have I squared times I, right? I squared equals what? I squared equals -1, and I is just I. So I to the third is -1I. And if I had I to the fourth? I to the fourth is I squared times I squared, which is -1 times -1. So I to the fourth equals 1. Exactly. Okay? The first two, though, are the ones we're going to use the most. We're going to use these two a lot today. Alright, so I want to talk about simplifying from a radical first. When we simplify from a radical with an imaginary number, the I goes outside the radical. So, for example, if I have the square root of -13, this negative comes out as an I. Can the square root of 13 simplify? So our final answer would be I square root 13. What if I had the square root of -4? The negative comes out as I. What about the square root of 4? What does that equal to? 2. So this would be 2I. Okay? So here is example number 1. Today, this will be like your problems 8 through 12. As you're referring back to your notes, I'm going to ask you to simplify. And let's say I want you to simplify the square root of -18. So we know this negative is going to come out as I. 18 breaks down into 9 times 2. 9 is 3 and 3. So we have a group of 3's that come out. We know we have to have this negative as an I, and left inside the square root is the 2. It is pretty easy. It's the same as what we were doing before. It's just if there's a negative inside, you put an I on the outside. Alright? Okay. I want to talk about graphing these wonderful things. Unless you guys, do you need another example of that? Anybody at all? No? Okay. Let's talk about graphing. Graphing. Complex numbers. Now, a complex number is always in the form A plus BI. So the A is a constant, and then the BI term comes last. It's always in that form. Now, when we graph, we're going to use a coordinate plane, but this axis is our A axis, and this axis is our BI axis. So if I wanted to plot 3 plus 2I, I would go 3 to the right on the A and up 2 on the BI axis and put a dot. that would be it. If I wanted to graph, how about negative 2 minus 4i? I would go on the a-axis, I'd go left 2, and then on the b-axis, I'd go down 4i. Put a dot. Okay? You only have 2 of those that are in your homework today. You just got to plot them, and you can put them both on the same graph if you want. I'm fine with that. All right? So now let's get into the real fun stuff. We're going to talk about simplifying complex numbers. All right. So our final answer always has to be written in this a plus bi form. And I want to talk about adding and subtracting first. Got to start with the easy ones, right? So, if I am adding two complex numbers together, let's say I have 3 plus 2i plus 4 minus 5i. When you are adding them, you are just combining like terms. So we add the 3 and 4 together, so we get 7. Then we add 2i and negative 5i, so we get negative 3i. Alright, subtracting them. Let's say I have 2 plus 5i minus 4 minus 3i. This time I have a negative in the middle. What do I have to do with that negative? Distribute it. Very good, Megan. We got to distribute it. So the first one's going to stay 2 plus 5i. I'm going to distribute a negative 1 through that parenthesis. So negative 1 times 4, negative 4, negative 1 times negative 3i is positive 3i. Then I'm going to collect like terms. 2 and negative 4, negative 2, 5i and 3i is 8i. And that would be your final answer. Okay? Let's talk about multiplying. Alright, we're going to start. This is where it starts to get a little bit more fun. Not quite as boring. Multiply. I can't spell. Alright, so let's say I have 3i parenthesis 2 plus 6i. When you have a term outside the parenthesis, we have to distribute. Alright, so 3i times 2 is 6i. 3i times 6i is 18i squared. But we decided that I squared equals something. What does this I squared equal? It equals negative 1. So technically this term is negative 18. Right? So we have 6i minus 18. But it has to be in a plus bi form. So writing it in the right order, it would be negative 18 plus 6i. Anytime you see that I squared, you need to change it to a negative 1. Are you guys getting this stuff down back there? Okay. All right. That's okay. Here we go. So, actually, let's do example number 2. This is going to fit from 18 through 26. It's just going to say simplify in the directions. Alright, so maybe we have 3 plus 2i plus 4 minus 5i. What do we do? What do we do, Megan? Yeah, just combine like terms because it's got a plus in the middle, right? So, 3 plus 4 is 7. 2i and negative 5i is negative 3i. Alright, but what if it didn't have a plus in the middle? What if we had 3 plus 2i timesing 4 minus 5i? How do we multiply those together? What did we do to multiply two binomials together? Do you guys remember? I think you liked the FOIL method, and I made everybody else do the box. Okay? So we're going to do the box. 3 plus 2i goes on top. 4 minus 5i, I'm going to put down the side. Okay? This is when you multiply them together. 4 times 3 is 12. 4 times 2i is 8i. 3 times negative 5i is negative 15i. 2i times negative 5i is negative 10i squared. All right, now look at our box. First thing I want you to do is look at the box. That I squared is negative 1, right? So I want you to cross out your I squared and change the sign on this number so this becomes a positive 10. Now, every single time you multiply two complex numbers together, your diagonals both add together. 12 plus 10 is going to add together. What is 12 plus 10? 22. And negative 15i and 8i add together for a total of negative 7i. Okay? Let's do another one. Example number 3. Right? I am on example 3. Okay, thank you. Example 3, same thing I'm going to say, simplify. Alright, what if I have 3 minus 2i squared? What does that mean I have to do? What does this mean? This means I have 3 minus 2i timesing 3 minus 2i. How am I going to times those together? In the box. So I have 3 minus 2i times 3 minus 2i. 3 times 3 is 9. 3 times negative 2i is negative 6i. 3 times negative 2i is negative 6i. Negative 2i times negative 2i is 4i squared. What do I do to that last term I just wrote down? Yeah, so I'm going to cancel my I squared and make this a negative 4. Then I add my diagonals together. 9 plus negative 4, 5. And negative 6i plus negative 6i, perfect. Questions so far? Okay, so we've talked about adding, subtracting, multiplying. Now we got to talk about dividing. And there's two sections to the dividing, two different things I want to talk about. So, first, dividing by imaginary, maybe imaginary, numbers. So if you're dividing and your denominator is one term and it has an I in it, okay? So for example, let's say I have 3 plus 4i divided by 2i. Okay? I remember as a square root of negative 1. So we cannot have a square root in our denominator. Alright? Which means we have to get rid of it. If you're dividing by a single term, you are going to multiply top and bottom by I. Alright? So, we're going to times both the top and bottom by I. Remember that top is grouped together. Right? On the top, I times 3 is 3i, and I times 4i is 4i squared. Still okay? Alright, in the bottom, 2i times I is 2i squared. Now, what can we simplify in here? The I squared, right? This I squared is going to make this a negative 4. This I squared is going to make that a -2. So my final answer, because I got to write it in the right order, this should be -4 plus 3I divided by -2. Okay, so if there's just one term in the bottom, you multiply by I. You guys want another example of that? Yeah. Okay. What if we had just something like 17 divided by 4I? Can I have an I in the denominator? I cannot. So, it's only one term in the denominator, so I multiply by I. Whatever I do to the bottom, I have to do to the top. 17 times I is 17I. On the bottom, 4I times I is 4I squared. Correct. I cancel that I squared and make it a -4. So it's 17I over -4. All right? Doing all right? One more thing to talk about. Okay. What if it was a complex number in the bottom? What if it's not just one term, but it's got 2 in it? So we need to talk about dividing by a complex number. When you divide by a complex number, and when I say complex, that's when we have that A plus BI form, right? If I'm dividing by something that's a number plus an I have to multiply by its conjugate to top and bottom. All right? So, let me show you what I mean. Let's say I have 3 over 5 plus 2I. I have a complex number in the denominator. Now, do we remember what a conjugate is? All right, maybe we need to back up a second. Let's talk about what a conjugate is. If we don't remember what that is, that makes it a little difficult, right? So let's side note for a second. Come over here. Conjugate. Conjugate is the opposite I. So, if I have, for example, 3 plus 4I, the conjugate to that is 3 minus 4I. If I have 2 minus 5I, the conjugate is 2 plus 5I. All right, your conjugate is the opposite I. Okay, so we understand that? Okay, so in this one, if I'm going to multiply by its conjugate, what am I going to multiply by? Good, 5 minus 2I. And of course, whatever I multiply the bottom by, I have to multiply the top by, right? So on the top, I have a single number times that binomial. I'm going to have to distribute. So 3 times 5, 15. 3 times -2I is -6I. Over. How do I multiply those two together on the bottom? 5 plus 2I times 5 minus 2I. The box. Thank you, Megan. The box. So I'm going to put the box right here for a second. I have 5 plus 2I times 5 minus 2I. 5 times 5 is 25. 5 times 2I is 10I. 5 times -2I is -10I. 2I times -2I is -4I squared. And again, we cross out that I squared and do what? Make it a +4. What do you notice about this diagonal with the i's? They cancel. When you multiply by the conjugate, that happens every single time. So what do we have left? 25 plus 4 is 29. So this is your final answer. Okay? All right. So last example then. What am I on? 5? 4? Only 4? Example number 4. Yeah, I didn't name some of the other ones. Again, it's going to be under simplify. And let's go with, how about 2 plus I divided by 2 minus 3I. All right. So I have a complex number in the denominator, which means I have to multiply by its conjugate. Very good. What is the conjugate? Good. 2 plus 3I. Whatever I do to the bottom, yeah, we got to do to the top. Now, what do you notice we're going to have to do this time? Got to do 2 boxes this time. All right? Fun, right, Kaden? All right, on the top, we're going to multiply 2 plus I times 2 plus 3I. 2 times 2 is 4. 2 times I is 2I. 2 times 3I is 6I. 3I times I is 3I squared. The I squared cancels and makes it a negative 3. Adding this diagonal first, 4 plus negative 3 is 1. 6I plus 2I, 8I. That's the top, or the numerator. Second box is for our denominator. 2 minus 3I times 2 plus 3I. 2 times 2 is 4. 2 times negative 3I is negative 6I. 2 times positive 3I is positive 6I. 3I times negative 3I is negative 9I squared. I'm going to cancel my I squared and make 9 positive. Yeah, so it's just going to be 13. Questions? Okay. You write the conjugate the same. Okay? So when you go to do the FOIL, so like the bottom, I'm going to write. Yeah. Yep, conjugate's exactly the same. Yep. Anybody else? Okay. So your homework today is on page 253. 8 to 32 even. 8 to 32 even. I have already posted a picture of it in Google Classroom. For those of you that prefer to look at that instead of your book. Alright. And please show me all your work so I know what's going on. We're starting a new semester, a new marking period. It is all going to be new stuff from here on out. So you need to be paying attention. You need to be doing the work. You need to be understanding. If you don't, you've got to talk to me. Let me know if something isn't jiving, all right? Because we got to be building and building and building. Okay? Okay.